Hello and welcome to another dSPACE Learning Fix. Today we talk about the exciting topic, logging of ECU internal data. The increasing complexity of ADAS and AD makes it necessary to log huge amounts of data. Not only sensor data, but often ECU internal data is required. Today I'm speaking with Tim Forster, Product Engineer for Compact System Solutions at dSPACE. Hi Tim, and welcome to dSPACE Learning Bits.
Hi, Michael.
Now I have a couple questions if you wouldn't mind answering them.
Sure, just go ahead.
Perfect. First question I have for you today is why is it important to log ECU internal data when doing test drives? Is it not sufficient if all the sensor data is being logged?
Well, Michael, as it is often the case, this depends heavily on the use case. If you, for instance, only want to collect data to be able to later on train neural networks with that data, then logging ECU internal data may not necessarily be required. However, if, for example, data from some sensors that are on the ECU itself, like temperature sensors or acceleration sensors, have to be logged, then it might be necessary to log ECU internal data. Furthermore, if you want to evaluate and validate ADAS or even AD algorithms, then you may have to compare and correlate the data acquired by sensors, for example, from cameras, with the outputs of the actual algorithms. But more importantly, if the data you are logging is to be used later on for data replay purposes, then of course the ECU has to be set to a certain state before you can start with your data replay. Because, for example, when your data was logged while driving at a fast speed on a highway, then the ECU has, of course, also to think and believe that it is actually currently driving at that speed on that highway when you start replaying the data. So ECU internal data is a very important point for many data logging projects.
Ah, okay, very interesting. That brings me to my next question. Which interfaces and protocols can be used to log ECU internal data with dSPACE data loggers?
Well, on our Altera data loggers, we use RT maps by Intempera to log all kinds of data. This includes sensor data from, for example, cameras, LiDAR sensors, or ultrasonic and radar sensors. And of course, also bus data from, for example, CAN or Ethernet bus interfaces, including automotive Ethernet, of course, and furthermore, XCP data. XCP stands for the Universal Measurement and Calibration Protocol and is a protocol that's standardized by ASAM. And it's a protocol that is being used to access variables and memory contents of ECUs at runtime. So the XCP protocol basically uses events that are issued by the XCP slave, which is a piece of software that is implemented on the ECU. And these events are used to trigger operations by the XCP master, which is in this case the data logger. So this event-based mechanism allows us to log data synchronous to the ECU application. For example, each time a specific task is being executed on the ECU, a measurement by the data logger can be triggered through this event on the ECU. And the XCP protocol supports many different kinds of physical layers, whereas our RT-Maps software on the Altera data loggers supports XCP on Ethernet as well as XCP on CAN. And in addition to that, XCP also provides the ability to add timestamps to every message, so you can later on correlate the timestamps of the XCP data with the timestamps of data that is logged from other sources like a camera, etc. To make this more clear, I'd like to show you a slide I brought with me today. Here you can see the ECU with the ECU software in the lower gray box and the Altera data logger with the RT-Map software in the upper gray box. The blue box with the service tag inside represents the XCP service that handles the synchronization between the ECU software and the data logger. So after this task has been executed on the ECU, a read event is being triggered by the service, and hence the data logger reads this vector y from the ECU's memory and writes it to an MDF4 file. And this is being done exactly after this task has been executed, each and every time the task has been executed.
Wow, thank you, Tim. Now, what can I do if I do not have an XCP service on my ECU that allows me to access ECU internal data?
Well, Michael, many of our customers do either not have an XCP service in their ECU software, or even if they have an XCP service, the communication bus used for the XCP service does not provide enough bandwidth to log all the signals required. For example, if a CAN bus is used and it's used for other purposes also, and not only for XCP, then you can quickly reach the bandwidth limitations of this CAN bus. But for these cases, dSPACE has a dedicated product. This product can be hooked up to the ECU's debug interface in order to get access to all of the ECU's memory. In turn, the device then makes the ECU memory accessible for data logging over XCP on Ethernet. To better explain this to you, I also prepared a slide that shows our XCP on Ethernet device, which is called the DCI GSI2. Here you can see our DCI GSI2 interface. It's a modular device that gets connected to an ECU's debug interface, and on the other side, you get an Ethernet interface that provides XCP on Ethernet access and hence allows you to access all the ECU's internal data over Ethernet. Since each and every ECU may use a different microcontroller and a different debug interface connector, we designed this as a modular device with exchangeable PCBs that allow us to adapt to many different kinds of microcontrollers and debug interfaces. And we also have the ability to create custom specific adapters as an engineering. This device then allows us to perform time-triggered measurements without any software modifications to the ECU. So this means even if your ECU's software does not include any kind of service, you can still just hook up this device and perform time-triggered measurements. For example, every millisecond, every 10 milliseconds, or every 100 milliseconds, whatever you need. And in addition to that, if you integrate our dSPACE service into your ECU software, then you can also perform synchronous measurements that are being triggered by task executions on the ECU. However, this is of course optional. And in addition to that, the device supports GPTP time synchronization, so our data loggers can act as an GPTP time master, whereas the GSI2 can consume that time as a GPTP time slave, and hence you will get accurate timestamping. And now to summarize all this, I have the slide I've already shown to you earlier in another version that includes the DCI GSI2, because on the first slide we had an XCP service directly integrated into the ECU. So the XCP communication used the service on the ECU and one of the ECU buses, which could be CAN or Ethernet. And in this case, we have added our own interface, the DCI GSI2, that then directly accesses the ECU's memory and allows our customers to add XCP on Ethernet to almost any ECU, even if there's no Ethernet interface at all or no CAN interface at all.
Thank you, Tim, for speaking with me today and answering some important questions on this topic. For all of you watching, please feel free to visit our website at www.dspace.com and submit any questions or topics that interest you. Have a great day, everyone.
dSPACE, your partner in simulation and validation.